Hello. Okay, so I'm eating lunch, but my brain is coming up with a lot of things that I need to say because it might be cool. So, you see this torus, right? Donut shape. What if there's this game, right, where if you take this shape that's a torus, but pretend this isn't solid right now. Like, let's pretend that there's like let's pretend there's wires in this direction making this shape, like this. Then let's say that inside of that, right, like, and then occasional like wires this way, like as a circle. So this circle and this circle. Now imagine inside of this hollow wire-shaped torus thing from a wireframe, that inside of it are smaller toruses. Like this, if we take this small circle, right, from with this diameter, radius, whatever, and we make small little foam or some plastic or something else or wood or whatever, right, with some material, we make it a small, like, I don't know if we would make it a torus or if it would just be like a circle, but like, for now, let's imagine a flat circle, right? Like a circle in this direction, but like, let's make it a little bit thick, so it's actually a cylinder, but like really small thickness, so it's kind of a circle. But then imagine that each one of these circles, with like on the side that has a little bit of thickness, the cylinder, I guess, and it has a dot on it, right? Now let's say we put a bunch of these inside of the hollow torus, right? And then we give someone like a chart full of I guess coordinates with degrees. You can have the degrees either be in degrees or radians, whatever, but we have these circles filling up the complete inside of the torus, but you can turn them, right, because it's hollow, so like you can go like this, and you can turn where that dot is. And so then let's say the game is to figure out where to put, is to match the dots to the data. So like, you have the dots maybe all facing the same direction, right, or facing the same angle or whatever. And then you have to take the data sheet you get and you have to spin each one of them around so that it matches. So like, if you denote this part as 0 degrees on the big torus, or let me just do it how I have it here. If we denote this part as 0 degrees on the big torus, then if you have a data point that says 0 degrees for the big circle and like 90 degrees for the small circle, you would have to turn so that the dot at the 0 degree on the big circle was facing the 90 degree on the smaller circle. And then you have to do that for every single one. And of course you could change the number, I guess depending on how many data points you want, you could change the number of circles, cylinders, toruses, whatever, inside the hollow torus. Do that, right? Okay, so that's idea 1. Why? I don't know. Okay. 2, so I was talking about like a torus or like a cylinder or a circle inside of the hollow torus, right? Because I wasn't sure what it would look like or exactly how it would work or fit. But like, theoretically, right, just theoretically, it would probably be a cylinder because that's what the cross section would be. But then if we flip to a different idea, what if we put toruses inside the hollow toruses? Now this is a separate thing. This is not the game. But like, imagine if you have a torus, right? What if you have like a really big torus, right? And then within that torus, you have another torus this way. So like, we have a huge big hollow torus, right? And we have a smaller torus inside. First step, solid torus inside of another torus. Wouldn't that give us extra dimensions? because now hold up, because we could have the coordinates of this torus on like of this circle, and then we could have the coordinates of this circle, and then we could have the coordinates of the small circle that makes up the torus that makes up this circle. Right. But like if we had like a huge torus, my mind is insane. If we had a huge torus, right? And it was like a hollow torus, then we can make this second torus also a hollow torus and put more hollow toruses inside of it. Oh, that would be such a fun art project. Okay. Yeah, that would be fun. I don't know how that would be, like a 3D printer, maybe not. Like maybe you'd actually have to do like architecture and stuff with SketchUp and get some sort of material in which you could, whoa, my mind is going a million miles now. Okay. And you could get some sort of material, right? Imagine that this was like a human-sized torus, right? Then we would definitely have space to put more toruses inside of the toruses, and minimum another torus inside the torus that's inside the torus, right? But then what could that graph, and also does that actually exist as a graphing mechanism? Because I feel like that might be hard to visualize online or like through a computer model. Maybe not. Maybe it's actually totally doable. Like how would you draw that? Hold on. Okay, so I don't even know if I can draw this. Okay. So you would have a torus like this. Gosh, I don't know how to do this. Okay, so I guess imagine we have a torus like that. I don't know if I'm good at this. Okay, torus like this. Can you even see that? Can I see that? I can't tell if I can see that. How do I drew a torus over here. So this would be hollow, this whole thing. And then this thing, like on this side, would be the additional torus. And if we put that as hollow and then make it like another torus inside of there. Wait. Try that again. Okay, we have a torus. We have this torus. That torus is going to be a hollow torus, but then inside of that we can put all of these things that are toruses to fill it up in this entire direction, right? But then that torus would inside of it have these toruses filling it up in this direction, right? So like, obviously if we try to, like, the cross sections are cylinders. The cross sections are circles. If we make them really thin with some thickness, because you can't actually have a circle with no thickness, right? Technically they're all cylinders. Then we'd have like really thin cylinders crossing this entire thing, which would basically fill up most of the space. Now the thing is, if we're going to change the cylinder into a torus, then we're definitely not filling up the entire space. That may or may not be a problem depending on what we want to do, which I have no idea what we want to do. I just think that it's something we could do. If you fill up a torus with toruses and you fill that up with other toruses, so what would happen then? You know? Like, I feel like that could be a really cool amusement park ride. Like if you take a ginormous torus where you can fit like let's say that the smaller circle can fit like 5 people in it. With like the machinery, with the seats, so like people in seats, and 5, and then in the smaller circle. And let's say that you would put the seats in like around the walls, so like they would be facing towards the center. So like if you want to spin someone so much, you could put them on these walls, right? And you could be spinning them in this direction. So like, but this is the smaller circle, right? So people go inside of the circle. So like, imagine if we do that torus inside a torus inside a torus thing. And so we put the smallest circle with the people in it and have it be spinning around in this direction, but then have that torus be spinning around in this direction around the smaller torus, and then have that be spinning around the bigger torus like this, and people would be spinning in 3 directions at once. And maybe they'd understand how the Earth works, because the Earth spins in this direction while spinning in this direction while spinning around the sun. I guess this wouldn't be exactly right, because the Earth spins this way and this way. It's not, I don't think it just spins in 2 directions at once. I don't know if it makes the second torus, because the second torus is bigger than the first torus, if it's going to be inside this if the smaller one's going to be inside the bigger one, then we can't have them be the same size. But yeah, that would be interesting. And then it could also be some sort of art exhibit where we could have Imagine such a cool slide park, right? Where we have this huge torus, and we're gonna have a slide going from like a huge torus that's also hollow, that can fit people inside, and people can be on top of it. Like maybe it's made out of wood or something similar, whatever. And so then let's say that when you get to like one point, like at the top, let's say it wouldn't be this, I think this would have to be a lot higher, this part of the circle, but imagine there would be a slide going from here all the way down to this side, and then there'd be a slide going from here maybe halfway, and then there'd be a slide going from here maybe a little bit to the top thing. Maybe there'd be like a small bridge over here, but then there'd also be a hole so that you could slide, so like you could have like a ladder or something here, and then you could slide inside, like on the inside this way, and come out on the slide over here and have a few of those also. And then, or like on this side, right, like going on this direction, this side, have people slide out that way, or a little, even maybe a little bit diagonally, in some of them, right? Because this is all curved. You could make so many slides out of curves and have this so much space inside, so that you could have slides over and under each other, and like that would be so fun. It's like one of those Minecraft or like marble things where like there's different things happening on different levels. They don't ever like mix with each other, but they're all happening, and like that would be fun. That would be a lot of slides. That would be a really cool playground. And like maybe at some points or it could just be like window points, like where you could just walk in and like look out the window and see everything that's happening, or have like a station on the top where you could just stand and look at things, or like read a book with some chairs, or like yeah. So what if no. Well, could people do that? No, I don't think that would work. I'm just imagining how cool of a playground you could make with a torus. Well, that's not what I was just imagining. That's what I'm imagining right now. The thing that I was saying that couldn't work, I think, had to do with monkey bars. And like, yeah, I don't think that one would work. Anyway, okay, I think my brain. Okay, I think my brain is fine. I wasn't even thinking of a playground originally. I was thinking of some art exhibit that you could walk into to look at the toruses. Great. That's fun. Or like, could you make some sort of really stretchy sort of fabric where, oh, no, I get it. This is the whole problem with the map projections. Because like, when I first was kind of being told about a torus, I was told to think about it as like a sheet of paper. You know, like if you leave this side of the paper, you come back on this one. If you leave from the top, you come back from the bottom. And so like, if you were to fold this around, you would get the smaller part of the torus, like the cylinder. And then if you were to connect these two sides together, you'd get the rest of the whole torus, which like makes sense to me. Then I'm like, if you take a sheet, you don't actually get the torus, right? Because you need things to stretch. So like these marks of the cloths and the ups and the downs, they would turn and they would have to stretch out if you were going to make a torus, because this is actually flat, and even though theoretically it's the same thing, if you were to take the lines from the torus and if they were like evenly spaced on the torus, they can't be evenly spaced on the torus. I mean, like, they can be degree-wise, but if they're degree-wise evenly spaced, then, like, the lengths wouldn't be the same, if that makes sense, I think. Because if you literally take a really stretchy fabric and put it around the torus, and then you... Actually, maybe we shouldn't even be having a stretchy fabric. Maybe it should just be a fabric that was sewn into a torus that isn't that stretchy, so it doesn't unstretch when you unfold it. So if you were to cut the torus into pieces after you had the fabric that was made in the shape of a torus, then you would get something like if I cut it, then I would have like this thing here, and I would have something smaller here and something bigger here. It might actually be like a sphere, no? Because if I had this be the center, right? And if I took this torus and I cut the fabric around this way, and I could unfold this half, and I could unfold. What would happen if I cut it here? I could unfold this, and I could unfold this, and theoretically they should be the same. If I'm cutting it in the halfway point, then this would unfold, and this would unfold. But then you would have to cut it somewhere. Oh, you have to come somewhere else here. Otherwise, you'd still have 2 layers like this. Because if I just cut it this way, then this would unfold, and this would unfold, but then this would fold into itself. So then I'd have to cut it again, and then I'd have a kind of line, but not really a line of like this. It would be a rectangle, kind of, wouldn't it? I don't know. Now I'm not really saying ideas. Now I'm just trying to figure out something which I don't even know what the question was in the first place. So, what if it wasn't a hollow torus? What if that beginning idea was like the same idea, except not inside a hollow torus? What if you just had like some sort of stand, right, in which you could put these cylinders so that you could put them and turn them, and then you would have to figure out where to put them. Or let's say that we had or the other way around, right? Like what if we had this be the cylinder and you had to turn all of these correctly in order to place the dots from the smaller circle into the correct position? Because like let's say like the 90 degrees is supposed to be at 90 degrees, but let's say it's supposed to be at like 0 degrees on this circle, you'd have to turn it so that it would be over here. So, but like then if you had that sort of game, why would that be helpful? Would that even be helpful at all? To who? Like, I just think, because like, would it be helpful for learning math? It might be helpful, it wouldn't really be helpful though for it would be helpful for understanding where you can put something, right? It would be helpful for understanding how to plot things on a torus that isn't like a computer, because it's a lot harder to do that on, like you can put the points of a torus in 3D coordinates, or you can even put them like on a space in 2D coordinates, like which just like the 2 angle measurements before you transform them into a torus using formulas into XYZ coordinates. But like that doesn't look like a torus, so it might be hard to understand / visualize. So maybe this could be helpful. I don't know. What could you want to graph, right? So like when I was graphing the tango dance, I was taking I was taking the 2 angle measurements in which one was the area of where the couple was within the dance floor, and the other angle was where the couple was facing in the room. So like you could turn around within like in one spot you could turn around, and you wouldn't have moved anywhere in like the dance floor, but you would have turned around a bunch of times around yourself. Or you could have walked around the entire dance floor without turning once, just like back and like this. And the point is, those were my 2 angles. Now, if someone wanted to add more angles, if we were thinking about the torus inside a torus thing, then like the angle that's the torus inside the bigger torus would have to somehow be interlinked / connected to that other data point, because the data points on the big torus, on like the big circle and the small circle of one torus, they can be independent of each other, right? Because they don't have to interact. But then if you take the big torus and you put smaller toruses inside of it, then this angle with this angle would still be independent, but the angle within this angle couldn't be independent from the big torus because it would be within this framework, right? Or would it all be independent from each other? Maybe they would be independent, and if they were independent, then maybe you don't need any dependent variables. Would that be another way of adding another dimension to a torus, just making it hollow? Is that actually what people do? Why don't I just Google this? Jeez. Okay, I'm gonna try that, and I have to finish eating lunch, and I have to go to class. See you later.